Hello everyone, welcome to the online video tutorial series of Computer Network subject. In this video, I will explain IP version 6 that is applicable on network layer. I am Jishan Sheikh, Assistant Professor in IT Department of LJ Institute of Engineering and Technology. In this video, I will try to cover basic need of IP version 6, why we are using IP version 6 instead of IPv4, how exactly IPv6 header format is structured, and difference between IP version 4 and IP version 6. So first I am discussing about what is the need of IP version 6 instead of IP version 4. So when we are talking about IP version 4, it's having 32 bits of range. If we are talking about the IP version 6, it contains 128 bit. So nowadays internet is widely used. Number of users of internet and internet devices are increasing. So when we are talking about the IP version 4 range, it contains total 2:32 address range. So it is near about to 4 million IP addresses. But the population of world nowadays, according to 2020, is 7.8 billion. So when the day is increasing, according to that, that range will be on the downside. So for that we have two options. One option is IP version 6 and second version is subnetting. So already we discussed what is subnetting in the IP classes. Now we are discussing how we are upgrade from IP version 4 to IP version 6. So when we are using IP version 6, from that the length is total 128 bits. So total number of IP addresses we can find with the help of IP version 6 is 2:32. Sorry, 2:128. So it is all about one person can find the 5 into 10⁻²4 addresses. So one person can find this number of address. So according to that, from the century we cannot find any solution of this type of IP addresses. So this is the basic idea how the particular IPv6 is solution of the limitation of IP addresses. Now how the IPv6 is introduced in our particular OSI reference model. So the same way our IP version 6 is analyzed in on our network layer. Where the IPv4 is reside, the same place our IPv6 protocol is residing. So our OSI and TCP/IP both the models are following this structure from application to physical, and all layers are independent from each other. So instead of IPv4, if you want to update IPv6, other layers are independent from each other. So when we want to try to replace, it only reflect on our network layer. Now how the exactly IPv6 are encapsulate the particular packet format. So the same way of IP version 4, IPv6 using the concept of encapsulation. In encapsulation, our IP packet is encapsulated with payload and header format. Payload contains the data where the header is containing the information. Where header and tailor is all about network layer property. What the data range is available, what is the sender information, what is the destination information, regarding informations are included in this field. So when we are talking about basic header field and payload, so IP header contains the many fields like that is used for the router to forward the packets from source to destination. Basically it contains the information that identify the sender, receiver and transport layer protocol which will be used. It is TCP or UDP. When we are talking about payload, so payload contains the data information, original data which will be sent by our IP protocol. So encapsulated format basically contains two things: header format that contains the information, and payload contains the basic information that will be sent by the user. Now we will discuss briefly how the IPv6 packet format is working. So IPv6 contains version bit, priority bit, flow label, payload length, next header, hop limit, and source and destination address. So let's discuss all these bits one by one. So when we are talking about version, it will identify which number of version is used by particular IP datagram format. If we are talking about the IP version 4, then that contains the 4 here. But here we are using IP version 6. So these 4 bits are used to indicate that version of IP, and that is indicated set by 6 number. Now next is traffic class. So traffic class contains 8 bits, and these 8 bits are divided into the two parts. The first most significant 6 bits are used to type of services that is used by our network layer, and that is known by the router which services are available to the packets. And the least significant 2 bits are ECN, that is for explicit congestion notification. The next label is flow label. Flow label contains 20 bits. Our flow label is identify the flow, how our data packets are moved from source to destination. It is set by the source and it should not be changed by any other router. So if in any sequence our data is streaming from source to destination, at the receiver side we can receive in the same sequence. So when we are using the streaming concept and real-time media concept, our data packets are successfully received with the help of flow label. Now next is payload length. So payload is all about how the data is transferring from source to destination. So the total length of our data will be identified by our payload length. So it is this field is used to tell how the router, how much information and particular packet contains its payload, because length contains the original data as well as header information. So exactly data information is containing by our payload length. Next is next header information. So next header information contains total 8 bits. It indicates two things. First is upper layer protocol. Our transport layer is using TCP or UDP, and it also contains the other information. So next header information is the next part of our destination address. If our particular header is containing other information, it will identify by the next header. Next field is hop limit. So hop limit is same as the TTL field which will be used in our IP version 4. It contains 8 bits and it is considered by the each and every router when the packets are moving from one hop to another hop. Next field is all about source address. So IP version 6 is containing 128 bits. So source address is contained by our IPv6 source address field. The same way destination IPv6 address contains total 128 bits and it stores the IPv6 address of the current destination host. Now we are moving to the in detail how the next header field is working. So here we can see that in this particular figure next header information is given. So if next header information is containing the information about two things, it may use the upper layer protocol or next header fields. So according to that, it will move to the particular data. If we are talking about specific upper layer header fields, it will give the pointer how the data is stored this particular header information. If we are talking about the place where the extension header is available, that will be defined in the optional part below the destination IPv4. So basically when we are talking about the next header field, it will identify which services are available from the particular IPv6. So number of services are available from the next header fields. For that specific value is identified. If the upper layer is using TCP, then it will identify value is 6. If the upper layer is identifying the UDP protocol, then number is 17. If the particular IPv6 header is containing the router header, then our value is 43. The same way, if the our IPv6 is containing ICMP version 6 instead of version 4, then it identifies the number 58. The same way, if we are not extending the router information, then it will be 59. If we are not maintaining any object of header, then we are maintaining 60 value. So here the number of values are available. According to that, next header value will be maintained and it will identify what is the header field is available next or not. Now this is the basic idea how our IPv6 is working, but we are comparing here how IP version 4 and IP version 6 headers are identify the different things. So here in the yellow addresses are available, that fields are kept from IP version 4 to IP version 6. The same field will be copied from the IP version 4. So that fields are version field, that is our first field. So that field the same field from IPv4 to IPv6. Second field is all about source address and destination address. So in IPv4, same particular field is available. So total 3 fields are copied from IP version 2, IP version 4 from to IP version 6. Now next is in the red color. So in the red color which are available, that fields are not kept in the IP version 6. So here header length, then identification, flag, fragment offset, checksum offset, and options and padding information. That fields are available in IP version 4, but in IP version 6, particular structure is removing this type of fields. Next is in the blue color. So it is the name and position of the change in IP version 6. That fields are taken from IP version 4, but name is changed. So that is all about type of services available in IP version 4. But that rename in IP version 6, that is traffic class. The same way, your time to live field is available in IP version 4, but that will be changed, and that is your hope limit. The same way here the data is about protocol in IP version 4, that is all about the next header. Now the remaining is in green color, that is the newly remain in new field in IP version 6. That is all about flow label. So flow label is newly introduced in IP version 6, that is not available in IP version 4. So this is the basic comparison of header. Now I am discussing last what is the exactly difference between the IP version 4 and IP version 6. So our first difference is IP version 4 contains 32 bit of length, where IP version 6 contains 128 bit. In IP version 6, fragmentation is done by the sender and forwarding routers. But here fragmentation is done by only routers. Sender is not responsible for dividing those data. So IP version 4 contains fragmentation and reassembly both by router and sender, but V6 contains only by the sender. Next is no packet flow identification. So as earlier we see, flow label is not available in IP version 4, but IPv6 contains the process of IP flow label, and that field will be added in IP version 6. Next is options field. So option field and padding field is available in IP version 4, but these fields are not available in IP version 6. Next is all about the ARP protocol. So ARP protocol is mapped to the IPv4 from IP address to MAC address. But ARP is replaced here with the neighbor discovery protocol. So if we want to find the IP address, MAC address from our IP, in IPv4 we are using the ARP, whereas IPv6 contains neighbor discovery protocol. And we are talking about broadcasting message that is available in IP version 6, but IPv6 is not available with the broadcasting message. And the last difference is all about static IP address. So our DHCP, which is required to configure our IP addresses, where here all things are auto configured. So this is the basic idea how the IP version 6 and IP version 4 are differentiated from each other. So thank you very much for watching this video.